James Joseph Heckman is an American economist and a Nobel laureate. He is the Henry Schall Distinguished Service Professor of Economics, Professor of Law at the Law School, and Director of the Center for Economics of Human Development at the University of Chicago, a Senior Research Fellow at the American Bar Foundation, and Research Associate at the National Bureau of Economic Research.
Jim J. Eggman received the Nobel Prize in Economics along with Daniel McFadden for his development of theory and method for analyzing selective samples in 2000. His is microeconometric as the data and policy driven. In his econometric work, Eggman developed a way to deal with what is known as the self-selection problem that lead to biased data sample. Econometric is a branch of economics that unites economic theory with statistical methods to interpret economic data to design and evaluate social policy. Economic theory plays an integral role in the application of econometric method because the data do not speak for themselves on many questions of interpretation. Economics use economic theory to guide the construction of counterfactual and to provide discipline on empirical research in economics. The production of large databases can be used to describe the economy, to test theories about it, to evaluate public policy in a major development of 20th century economy. Prior to the 20th century economy was largely a deductive discipline that drew on anecdotal observation and on introspection to test theory and evaluate public policy. Two conceptually distinct policy evaluation questions are often confused. There can be separation in major development in macroeconomics. Those questions are: what is the effect of the program in place on participant and non-participant compared to the no program at all or something alternative program? This is what is now called the treatment effect problems. The second and the more ambitious question raised is: what is the likely effect of new program or an old program applied to new environment? The second question raises the same type of problems as arise from estimating and the demand for new goods. Its answer usually requires structural estimation. The goal of structural economic estimation is to provide the ingredient to solve a variety of decision problems. Those decision problems entail such distinct tests as evaluating the effectiveness of the existing policy, projecting the likely effectiveness of the policy in different environments from the one where it was experienced, or forecast the effect of the new policy never previously experienced. Additional benefits of structural models are that they can be used to test economic theory and make quantitative statements about the relative importance of costs within a theory. In addition, structural models based on invariant parameters can be compared across empirical studies. Empirical knowledge can be accumulated within structural framework. The treatment effect literature has been to be extended to make such projection and comparison, and unsurprisingly, the required extensions are non-parametric versions of the assumption used by structural economic change. To make it specific, but at the same time keep it simple, consider the prototypical problem of determining the impact of taxes and welfare payment on labor supply. Following the conventional theory of customer demand, write an interior solution labor supply equation of hour of work, H in terms of wages, W, and the other variable include asset, demographic structure, and the like. Denote the other variable by X. Let U denote an unobservable from the point of view of the observing economist. As we shall see, unobservables play a big role in macroeconometrics. There is much evidence that unobservables are empirically important. Its derivative produce that ceteris paribus effect of the chain in argument being varied on H. Suppose that we wish to evaluate the effect of change in a proportional wage tax on labor supply. Proportional wage tax at rate T make the average tax wage W1 minus T. Assume that an agent correctly perceive the tax and ignore any general equilibrium effect of the tax. An additively separatable version of the Marshallian causal function is. This version enables the analysis to define the ceteris paribus effect on W and X on H without having to know the level of the unknown, where theta is a low-dimensional parameter that generates the P of equation. The parameter theta reduces the dimensionality of the identification problem from that of identifying an infinite-dimensional function to that identifying a finite set of the parameters. They play a crucial role in forecasting the effect of the old policy in different populations, in accumulating evidence across studies, and in forecasting the effect of the new policy. A linear parameter representation of H prime. Suppose that the goal of the analysis is to determine the effect of the taxes on the average labor supply on the relevant population with distribution. In case 1, we have data from the same population for which we wish to construct a forecast. In the sample from each regime, we can identify for the entire population, this function is knowledge of P is needed for the new population. This may entail a determination of P on different support from the use to determine P in the initial sample if the target population has different support than the original source population. At this stage, structural estimation comes into its own. It sometimes enables to extrapolate P from source population to a target population. A completely non-parametric solution to this problem is impossible, even if we adopt structural additive separatable assumption, unless the support of target and source population coincide. Some structure must be placed on even characterize the labor supply model. Parametric structure in traditional in the labor supply literature and version of linear parameter model dominate applied economical research. Knowledge for the target population is also required. In this context, exogeneity enters as a crucial facilitating assumption. In this case, if we assume that the distribution of unobservable in the sample as in the forecast of target regime is the distribution of unobservable in the target population, we can project a new population using the relationship this data challenge traditional econometric methodologies, problems that appear to be unimportant when examining aggregate average become central in analyzing microdata. This problem and the policy concern that motivate the systematic collection of macroeconomic data gave birth to modern microeconometric.